What does it mean for an object to be dense? We find that out today on A Moment of Science. Okay, all objects have some type of density. That's a physical property. Now, every object, no matter what it is, can be identified by that physical property, no matter how big it is, no matter how small it is. So a copper BB has the same density as a giant sheet of copper, okay, or a copper wire. It all has the same density because it is copper, all right? That's called a physical property. Again, we'll be learning about that more in the next chapter. But for right now, we need to focus on how to calculate density and what exactly density is, okay? So I have two objects here. One is a ping pong ball. One is a golf ball. Okay, and they are almost identical in size if you look really closely. Okay, now they vary in density. Okay, and the reason for that is this. Okay, if you were to grab a golf ball and a ping pong ball, okay, and kind of weigh them, the golf ball is more massive. It has more mass. All right, now they both take up equal amounts of space. All right, so to determine which one is more dense, we would have to use water. Okay, now when we have water, we understand that water has a density of 1. Okay, so the density of water is equal to 1 gram per milliliter, okay? 1 gram per milliliter. So these will either sink or float when they're placed into that substance, and that's how we know what the object's density is. If it's more dense than water, it sinks. If it's less dense than water, it floats, okay? So that means it has a density less than 1, it's going to float on water. If it has a density more than 1, it's going to sink to the bottom. Okay, so I have these two objects. One is more massive than the other, but they both take up about the same amount of space, the same volume. So if I take them and put them in water, much like I've done right here, okay, you can see what happens. All right, the ping pong ball floats on top and the golf ball sinks to the bottom. All right, so that means that mass, or the amount of stuff there is, okay, actually plays a big role on the density of an object. Okay, so the more massive it is, usually the more dense it is. Now that's not necessarily the case in all respects, but in this case it is, okay? The more massive object was more dense, so it sunk, the less dense floated. Okay, and it has a less mass as well. And we can actually calculate the density of objects using a specific formula. So the formula to calculate density is simple, okay? Density, we love density, okay? We love density. So this is a heart, okay? And if you were to slice that heart in half, just like this, you would see the formula for density, which is mass divided by volume. Okay, so to calculate the density of an object, we take the object's mass, which we can get from a scale, and divide it by the object's volume, which we can calculate either by using a ruler, if we're going length times width times height, right? Or using water displacement like we did in class, right? So you take the object's mass and divide it by the amount of space it takes up. The amount of stuff the object has divided by the amount of space it takes up. That tells you the object's density. Okay, now I told you again that density is the same for any object that is made of the same substance. So that means that copper is always going to have that same density. Steel is always going to have that same density, all right? Now that's important. But to calculate it, all you have to do is find the object's mass and divide by the object's volume. Now let's try a sample problem, okay? Let's say we have an object that has a mass of 50 grams, okay? So it has a mass of 50 and it takes up a volume of 100 milliliters, okay? 100 ml. All right, so if we were to calculate the density on that, all you would have to do is put 50 in your calculator and divide by 100. 50 divided by 100 would give you 0.5 grams per milliliter, okay? Remember that you always have to put your units on your numbers, no naked numbers, okay? So grams divided by milliliters, those are your units, okay? So the answer right here would be 0.5 grams per milliliter. Another example, okay? Say we have an object that has a mass of 25 grams, okay, and takes up that same volume, 100 milliliters, okay? When we calculate that, that would give us the number 0.25 grams per milliliter, okay? Real simple. It's not a tough calculation, okay? Now, would these objects float on water? Go ahead and write that in your notes. If you think yes, write yes. If you think no, write no. Okay, remember that the density of water is 1. Now remember, no two objects on this periodic table have the same density, but density can be calculated with mass divided by volume, okay? Get ready to come to class and calculate a whole bunch of density. We'll see you next time on A Moment of Science.